Coming up, a lot of launches.
Dragon returns to Earth.
Dream Chaser modifies itself for science. Plus, we're joined in studio by Copenhagen Suborbitals. Stay tuned. Tomorrow begins right now.
Oh, it's beautiful, Mike. Got the flag up now. You can see the stars and
Private space station.
And welcome to Tomorrow, episode 7.32 for Saturday, October 25th, 2014. My name is Benjamin Higginbotham. With me, as always, my beautiful, lovely, wonderful, and talented wife, Carrie Ann Higginbotham, will be your hosts for this episode. Now, before we get started, I wanted to give a huge shout out to all the patrons of Tomorrow who've helped to make this specific episode happen. These are the people who've contributed at least $10 to this specific episode. Every single dollar helps. We are a crowd-funded show, so your contributions are what help keep us on the air. You can learn more about that over at patreon.com/TMRO. Now, we have an action-packed episode this week. We've got Copenhagen Suborbitals on, and so I want to get straight into that interview. So we're going to kind of go through the news pretty quickly, but there is some news. We wanted to start off with some launch coverage. First up, China. We don't get very much launch coverage, so this is all you get.
遥感卫星22号送入太空，我们现在看到的就是现场的画面。遥感卫星22号呢，主要用于科学试验。
So that's a Yaogan 22, which was launched via a Long March 4C rocket. That was on October 20th at 0631 Universal Time. This is one more. I'm going to have to air quote. This is the crop yields and disaster relief satellites, which we all believe to be military satellites, military observing satellites for looking at stuff out at sea.
No, they're just looking at crops.
Sure, I guess that's of military importance. That was actually the 7th Chinese flight of 2014. Then we had a Proton launch, Express AM6. I love the audio delay.
That's so cool.
That launched October 21st at 15:09 Coordinating Universal Time. That is the AM6 is a 15-year satellite. It's for high-speed broadband communications, both for government and for commercial usage. The commercial use would be like DirecTV to the home, basic communication, internet stuff. And then it's also going to allow the Russian president and other government leaders to communicate with each other, which is, okay, cool. So that was a AM6 satellite that launched a little bit earlier on this week. And then, of course, China had their 8th launch of this last week. This is the Chang'e 5 T1. Now, they try to hide this. Go ahead and go to it. Oh, is it? Okay, yeah, there you go. That's right. A viewer that is way too close.
Way too close.
Way too close to this rocket. Captured this on either an iPhone or some sort of mobile device, so we actually have, for realsies, China footage in high definition, unfortunately still only 30 seconds long, but still an absolutely gorgeous flight. That launched on October 30th at 1800 Universal Time or so. We don't actually have an exact launch date from China on that one. This is the precursor to Chang'e's 5 lunar sample return mission. Basically, this is going to go up, it's going to sling around the moon, and it's going to come back in, and it's going to skip off the atmosphere a little bit to try to slow down and come back in. It's basically testing out the technologies for their lunar sample return mission due up a little bit later on next year or late this year. I don't remember which.
Yeah, I think it's next year.
I think it's next year as well. We also have some space news, so we're going to turn it over to SpaceX News. Turn it over to Space Mike to talk about what's going on in SpaceX land. Mike, what's going on there?
Hello, everybody. There's some very cool things going on. First of all, the Dragon capsule for CRS-4 has returned to Earth this morning. It made a splashdown in the Pacific, and it was very cool. They were able to unload all the cargo that we've talked about in previous episodes, and they were able to return a lot of the sensitive down mass from several experiments that they've been running on the ISS and return those safely to Earth. And the capsule is going to be recovered and then is going to be brought into port in Los Angeles, where it will be processed, and all of the useful information and useful payloads will be collected, and it will be very good. They were able to replace their weather satellite capabilities that they had on the ISS that were lost with QuickSat, and that was done by the RapidScat instrument, which was installed on the Columbus laboratory. And something that's kind of interesting about that is it was in the trunk section of the Dragon, and that was the second time that a payload had to be removed from the trunk using the Dexter arm that's on the ISS, the Dexter manipulator. So that was very cool. Only took about 5 hours of free flying and about a 10-minute burn. And like I said, it's been recovered this morning, and it's very good, very awesome that they were able to have no problems with this mission, it seems.
And also, I think you had awesome milestones with the Merlin engine as well.
That's right. SpaceX has successfully completed their construction of their 100th Merlin engine. And this is kind of significant because although their competitors have built several more engines, as far as the engines that have actually flown in space, SpaceX has flown 80 of these Merlin 1D engines. And compare that to the RS-68, which has only flown 41 times on the Delta, and even the RD-180, which has only flown 55 times on the Atlas. So although the RS-68 is an indigenous rocket and the RD-180 is not Russian-built, the Merlin has now flown more times than both of those engines, which have been in service since the early 90s. So that's a pretty significant milestone.
All right, and the final news, I think, is the what Elon had to say this last week.
That's right. Elon Musk had something very interesting to say about their next powered descent of one of their first stages, and that it's going to be landing on a barge. So let's listen to Elon's own words.
So for the upcoming launch, I think we've got a chance of landing on a floating landing platform. We actually have a huge platform that's being constructed at a shipyard in Louisiana right now, which is, well, it's huge-ish. I mean, it's about 300 feet long by 170 feet wide. That looks very tiny from space. And the leg span of the rocket is 60 feet. So, you know, you've got, and this is going to be positioning itself out in the ocean with, you know, with engines that'll keep it, and it'll try to keep it in a particular position. But it's tricky. You've got these big rollers and GPS errors. So, but you know, so it's not anchored because it's like out in the bloody Atlantic. So, that's we're gonna try to land on that on the next flight. And if we land on that, then I think we'll be able to refly that booster. But it's probably maybe not more than a 50% chance or less of landing it on the platform for the first time. But there's a lot of launches that will occur over the next year. So there's at least a dozen launches that will occur over the next 12 months. And I think it's quite likely, probably 80–90% likely, that one of those flights will be able to land and refly. So I think we're quite close.
Very exciting, very exciting. Elon Musk just said that yesterday at MIT. And they, as most of you know, they have successfully landed on water before. All those stages, one was recovered, one was not, but they weren't really reusable. So just like Elon said, this would be very cool if they were able to do this, because they could start reusing their rockets right away without having to get all the certification and get through all the red tape they need to start landing on land somewhere, you know, at Cape Canaveral or in California or wherever. So this is a nice way of getting around that to make sure that they can do what they have been claiming and hoping that they can do all along.
Sounds great.
Back to you guys.
Hey, thank you so much, Mike. And finally in our news today.
Last but certainly not least, a Dream Chaser is doing a Dream Chaser for Science, or DC for Science, which is a variant...
For science!
For science, duh. It's a variant that would offer free-flying microgravity science laboratory to commercial and international customers. It's designed to fly independently for short or extended durations. It can be crewed or uncrewed. I love all these either-ors. Customers will maintain scientific and intellectual property rights free from the federal research laboratory regulations that govern the International Space Station, which is a very, very big deal. And Dream Chaser Chaser, as you know, because it's basically a little space plane, has a wide range of landing options around the world, getting the payload closest to wherever the customers may need or want them, which is a very exciting thing. Look how cool that looks.
And that's actually, you said wide range of landing. That's a wide range of launching, right? Because
I suppose,
that's
yeah.
the Strato launch that they announced not that long. I think we talked about that in our last week's show. But if you look at the very tip of the middle section, like that is the Dream Chaser at the very, very front, just that little itty bitty piece. Teeny tiny little shuttle.
So cute.
That's the Dream Chaser right there. So yeah, and so wide launching capability, wide landing. Although they did not announce that the Dream Chaser for Science would be able to launch on the Strato launch, but I assume that because they're kind of in this mode of let's get money from wherever we can.
Right.
Whatever you want. If you can pay for it, you can have it on Strato launch. If you want it on a regular
enough.
Atlas V, you can have that. I think they just want to make it a commercially viable vehicle. And by the way, good for them.
Yeah.
Absolutely.
No, absolutely. Way to diversify, guys.
All right, we're going to take a quick break. When we come back, Mads Wilson from Copenhagen Suborbitals is in studio, and we're going to be talking about what they've been doing. This is going to be epic. Stay with us. We'll be right back.
Welcome. Great to have you all here. You're in a building called FAITH. FAITH stands for the Final Assembly, Integration, and Test Hangar. And it's where we're essentially putting together the next vehicles.
It might seem like a long time since our last powered flight. What really has been happening is ground testing. But we take the feather actuator, the thing that makes the feather go up and down, and we run it 30,000 times. And we find that it's extremely reliable. The rocket motor systems have been tested on the ground dozens of times, and we're going to do dozens more. So the ground testing that happens is actually, at this stage, almost as important as the flight testing.
To have a space line, you need a fleet of spaceships. So this is serial number 2, Spaceship 2. The plan is to get it on its wheels by the end of this year.
This is one of 2 simulators that we have. This is set up as a White Knight 2 simulator. We have another simulator set up as a spaceship simulator.
It's a dynamic seat, so it's the first seat that has ever been invented that basically reacts to the G-forces and the environment.
Can I just say one thing? If any of you have flown on Virgin America, Adam was responsible for us winning 7 years of wonderful awards with Virgin America.
We announced that we're building a vehicle called Launcher One, lets you buy a ride to space for your satellite that you'll pay less than you pay anywhere else. We are building Launcher One in-house, and that is really from the tip of the vehicle to the tail of the vehicle.
So when I came over from NASA to run Galactic, we had about 25 people, and that was in 2010. And now we're about 425 people. We have built a world-class space operations, space engineering, and space manufacturing team. Amazing people who have come from all over the country, in some cases all over the world, to be a part of something that they feel is going to change the world.
And welcome back to Tomorrow. Now, before we get into our interview with Mads, I'd like to give a huge shout out to all the patrons of Tomorrow who helped to make this specific episode happen. Now, these are the people who've contributed at least $5 to this specific episode. Again, we are a crowdfunded show, and every single dollar helps. You can find more information over at patreon.com/TMRO. All right, Mads. So first off, welcome to the United States.
Thank you.
You just flew in an obscene number of hours to make it specifically for our show. You're here for no other reason. That's what I'm going to believe in my brain, at least.
Precisely.
Tell me about Copenhagen Suborbitals. Well, actually, let's not even do suborbitals. Tell me about you guys as a group, because you do a lot more than just rockets.
Yeah, precisely. We do. Basically, we are just a group of about 50 guys who originally got together around the project of building a submarine. Mm. And that resulted in not only just one, but actually 3 submarines. Ending up
as one does. You just like, hey, I'm going to build a submarine, but why build one when I have 3? All right, cool.
Yeah, and that ended up with actually the world's biggest amateur-built submarine, the UC-3 Nautilus, which takes 8 people. It's a huge machine. That was completed, and she's been on land for the past 3 years, undergoing refurbishment, and we plan to put her into sea next year again, next summer. And then in 2008, Copenhagen Suborbitals started,
Mm-hmm.
and we started building a rocket. And our purpose, what we want, is to be the first all-volunteer amateur organization in the world to actually put a man in space.
And you're making pretty good strides to doing that. Not that long ago, you had your Heat 2X engine test.
Yeah.
And, before we show that footage, because we have it, and it's amazing footage, and we're going to show it, one of the things I love about Copenhagen is that you guys are willing to show everything. You're doing this for fun because you want to do this. And, you get all these other companies out there, and, any failure they can't show. And if it's not absolute perfect success, they're not going to show you. You guys, on the other hand, you're like, wasn't that explosion awesome? So here, why don't we, you've got this footage. Check this out. This is your Heat 2X engine. We've actually shown this before, although this is slightly different footage. Go ahead and roll it. So what are we looking at here?
We are looking at first some footage from our distance cameras, where you can actually see the launch. You can see how the engine fails. And a huge fire starts, and this is actually this is footage from a GoPro camera that was attached about half a meter from the engine itself. The purpose of this camera was to look and see how the rudders, as you can see, how they performed. You can see here we have main stage for just a fraction of a second. That actually looks good, and then we had a collapse of the inner wall in the engine nozzle, resulting in all the alcohol, about 600 liters, spilling out in a couple of seconds. But look at that. It's a virtual inferno, and you can see
it is. I mean, it does. It looks like something out of a movie at this point.
Yeah, here you can actually see the strips holding the GoPro melting, and the GoPro starts spinning down into the flame pit. Eventually, in a second, it will land in the water with the camera up, so it's actually filming the fire in the test stand from below the water. And this is actually what saved the camera, we believe. We managed to take this GoPro apart and actually get the footage out of it. You can see that looks amazing.
It does.
And I must say, I was standing in the bunker about 100 meters from the fire when we did this test, and the heat, the sound, and the sight of that was simply just amazing. And of course, all the people, we have been working a couple of years on this rocket, and of course, people were disappointed because we were supposed to launch that this summer. But then again, after maybe 10-20 seconds, you could also see the light in people's eyes again, and everyone was just like, well, let's go build another one.
Wait, you get to build another one. You were talking earlier before the show. You had let the I'm thinking ammonia, alcohol, pushed all the way through the engine way too rapidly, and you were just left with liquid oxygen, and it sounded like a
yeah, precisely. Actually, because all the alcohol spilled out so quickly, but the oxygen, as the oxygen comes into the injector directly, nothing happened there. It just went through the injector as it was supposed to. And that actually turned the engine into a big trumpet. So you cannot see it on this footage, but some of the other videos we have, and I would be happy to share it with you guys, you can actually see the rocket standing like a huge wounded whale, just moaning and sounding like a big trumpet. That was amazing.
So you've got this engine that's not quite performing like you want, just kind of going, oh,
yeah, precisely.
I don't know, what have you done to me?
That was pretty much what it sounded like.
All right, so you've got this engine. Well, not anymore, but now, and actually, we have some additional footage. So this is the before shot, right?
Yeah, this is maybe about a month or so before the first test attempt, where we were mounting the TM65 engine into the engine compartment of the rocket. And maybe if we skip to one of the other shots,
I think we've got the after shot. Oh, there's a welding random.
Yeah, precisely.
Hey, look, dude, welding.
This is Andreas welding. Here you can see this was part of a series of photos we did on the autopsy of the engine. And if you go to our Picasso site, you can actually see all the other images from that day. What we did that day was, by the way, we sent emails out to our subscriber base, and we put on our Facebook that everyone was invited to come and visit and see when we performed the post-mortem of the engine. And that was pretty amazing. A lot of guys showed up, and we had a good time, and did some rocket talk while we took the engine apart.
How did it go? I mean, so you've got this this dead engine now. You're going to need to build a new one. What did you learn from this dead engine?
Well, what happened was, as I said, basically that the inner part of the nozzle simply imploded. Actually, there was something wrong with the structural integrity of that particular section. So what we're going to do now, we're going to go back a little, and we are building a smaller test engine to figure out these specific problems.
Okay.
And once that is working, we're going to scale it up to not actually this size, but almost double the size of the TM65. And that will eventually be the engine powering our newly designed Spiker rocket, which will hopefully fly its first mission in 2016.
Now, is that the rocket we have the infographic on?
Yeah, it is.
All right, let's take a peek. I think you just had that, Dutta. It's the that one right there.
Precisely.
So what are we looking at in this rocket?
We are looking at, from the past 6 years of experience, testing all different kinds of technologies and trying out different things. This is what we believe is what it takes to put a man in space. Just good enough. And as we talked about,
that's your thing, though, right? You don't want to do all the bells and whistles. You're all about what does it take? You just enough to make it happen.
Precisely. This rocket is going to be about 1 meter in diameter.
Okay.
So obviously the capsule is not very big. There's not much room for the astronaut, and he will actually be sitting like in a cannonball position within the rocket, and that should work. It's not going to be a very pleasant ride.
Well, let's talk about that. So you're going to get into suborbit in 90 seconds.
Yeah.
So from dead stop to suborbital space in 90 seconds.
Well, actually, we have a main engine cutoff in 90 seconds, and then we will have a couple more minutes before we reach apogee. Yeah.
Oh, actually, no. Let's back that up. So it's even worse than that. You're launching from a ship, right? Yeah. Actually, we have a picture of that as well. I'm making our director there you go. I think that's your launch platform, right?
This is our launch platform. One of the challenges we have had in our project is, where do you launch a rocket if you don't have a rocket test facility?
Sure.
If you don't have access to the Mojave Desert or Cape Kennedy or Vandenberg or whatever, what do you do? Obviously, we would like to do a land launch if we could, but we couldn't, so we have had to build our own launch platform.
As one does. You build a submarine, you build a rocket, so let's just build a launch platform.
Precisely. And this is the MLP Sputnik.
All right. Does it bing a lot?
Motorized.
No. Anytime you're on it, it should beep at you or something. So
and she's actually a self-powered platform. She sails by herself.
Mm-hmm.
And yes, we built. You can see the image here is from a launch escape test we did a couple of years ago on one of the capsules.
So the reason I bring up the platform is because you've got someone, your poor lab rat, strapped inside of this rocket, cannonball style, and you're launching from that platform, and you're out at sea, and as you mentioned, you're sitting there, and your ship is going to ebb and sway and kind of rock in the ocean, right? But they're sitting up here. So for how long are they going to be sitting up there doing this? Right?
Well, obviously, we need to mount the astronaut on top
as
of the
one
rocket.
does.
Actually, probably we would need to screw him into the capsule. I'm not sure. We haven't figured out that part yet. But he will be sitting there for quite some time.
All right.
On platform, out at sea, that is wiggling a little bit. But remember, he will be maybe 15 meters up in the air in the capsule.
So that little bit of wiggle is going to be magnified a lot when he's 50. So first he's going to have to endure that for an hour or two, maybe, assuming you launch, right? Because weather, technology...
And assuming we don't have any problems.
Sure, absolutely. Yeah. I mean, many reasons that can scrub a rocket launch. So then, okay, great. That's the first thing you have to endure. That's just part one. Now, part two is 0 to really fast in 90 seconds. How much G-force are you going to take head down?
Around 3 or 4. It a little bit depends on how the engine performs. But yes, he will be accelerated from 0 to about 3.5 times the speed of sound in 90 seconds.
Okay, so then you've got that. All right, so now you detach, you keep going up, you reach your apogee. Then what happens?
Then, obviously, the capsule and the booster will separate, and the capsule will start its descent, as will the booster. We will then deploy a little balloon to make sure that we have some drag that actually will pull down the capsule, so it will have the bottom down. But it takes some time before we actually reach the atmosphere. So to begin with, the capsule will be tumbling.
All right, so to be clear, your guinea pig is going to be out of the ocean doing this for a while, take about 4 Gs for 90 seconds, and then they're going to potentially be spinning an XYZ axis essentially, right? Because you could have an X, Y, or Z spin while you don't have any atmosphere up there, until you actually have enough atmosphere to kind of pull you down, at which point you'll probably start to spin a little bit inside of the atmosphere before you come down.
Breakfast is a no-go here.
Do you have a volunteer for this?
We do. We actually have several. Believe it or not, we have 3 guys internally, kind of competing to be the first one.
You need to put them on camera, and you need to have like a voting system. I mean, make a contest out of that. That would be so much fun.
Probably one of them is first in line because he's very short. We need a quite short person. But actually, while we're talking about this, we get about 5-ish on average applications every week.
To be the astronaut?
From people all over the world who wants to be the astronaut.
Wow. That's amazing.
So finding someone to do this will not be a problem.
You know, even knowing all of that, I kind of want to do it myself. It sounds like it would be a lot of fun. Sickening, but fun. And how cool is that going to be the first person to go to space in a vehicle like this? It's never been done before.
It's not going to be pleasant, but you will survive it.
Yeah, that is going to be really freaking cool. What do you do then? So let's just say you do this, right? You put a person, I'll say man, but it doesn't have to be a man, right?
No,
you put a person, you put a person into suborbital space, then what?
Well,
more submarines?
Obviously, I cannot say. No, I think
you got to work on your giant lasers.
I think we have covered submarine stuff, but obviously I cannot say. But I would be surprised if we were stopping there, because we simply we just have to. We got to do this. We are having so much fun, and this is such a dream for all of us that of course we will build something else.
All right, so what we're going to do is we're going to take a really quick break, and then when we come back, we're going to keep you here, and we're going to talk about some of the stories you have, of things that you guys have been doing over at Copenhagen Suborbitals. So stay with us. We'll be right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with some expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving, the heat keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
And welcome back. So before we continue our interview and talk about, we'll get into some of the questions on the chat room if we have some time. I did want to give a big shout out to all the Patreon Plus subscribers who've helped to make this specific segment of this episode happen. These are the people who have contributed at least $3 to this specific episode. You can get more information on that over at patreon.com/TMRO. All right. So, you're building this rocket.
Yeah.
You've got an engine that you've blown up, but you're going to build another one. Are you going to do anything new with this new engine, by the way? I mean, you said you're going to size it down, make it smaller, but what other things you're going to do to your engine?
One of the main things is that we are going to try a different manufacturing technique.
Okay.
Actually, we are going to build the bell and the nozzle of the engine pretty much the same way that the SpaceX does.
Okay.
We're going to use metal spinning.
Okay.
Where we simply take a huge sheet of metal and spin it up on a form, and we will make it a little bit more round to avoid some of the curvatures that messes up the combustion and causes heat problems.
Because right now you're kind of a boxy design, and so you got
the design we're using now is very similar to and actually derived from the design used on the Redstone engine. Also, we're using the same kind of fuel and everything.
And actually, that was a question from earlier. I think Mini Elon in the chat room asked, is there anything special about your engine that sets it apart from other engines?
No.
So it's just,
Not at
you
all.
went back and you said, this worked in the 60s, we can make it work now.
Like we talked about before, our goal and our purpose is not to figure out anything new. We're not trying to invent something. We're not trying to build a super efficient new 300 bar engine. What we are trying to do is to build a rocket that can put a man in space and do it with ordinary components, ordinary off-the-shelf stuff that you can buy in a hardware store, using the simplest possible design.
How do you pay for all this?
We are also a crowdfunded project. We have around 1,100 support members right now from all over the world. And as I said before, one of our VIP supporters is a little 80-year-old guy who is contributing with about $2 of his allowance each month.
That's awesome.
Because he thinks that this project is so amazing. But we have people, giving everything from $10 to a couple of $100 a month, and simply because they like us, they like this, they like to share and be part of the dream, this dream that we can actually do something like open source space flight for all mankind.
So we've got a lot of space geeks who understand crowdfunding, who are helping to crowdfund this show. If they want to help crowdfund you, where can they go to do that?
Just go to copsop.com, our website.
So COPSOP, because spelling out Copenhagen Suborbitals.com would be a bit long. So copsop.com.
Precisely, and there's the little support form you can fill out, and that's it.
That's really cool. Are there any rewards or anything? Do you get like on a mailing list? Do you get to see videos or anything?
Yeah, you get. Of course, you get the mailing list. You get free access to all our events if you want to stop by and see an engine test.
If you want to just stop by, I think we have a map, Dutta. Do you have a map showing where they're at? So there you go. So where are you on that?
This is actually Copenhagen. This is a Denmark scene from space. A view that our astronaut hopefully will see one day. And you can actually see the launch area is just in the middle, bottom middle of the
that little black dot, basically.
Yeah, that's actually an island, but just south of that is our launch area out in the Baltic Sea. But yeah, we are pretty much far away from everything, unless if you are living in Denmark, I guess, in Scandinavia. But actually, we have people coming. Just a few weeks ago, we had a guy that emailed me from Australia.
Oh, well, all right.
He said, well, I'm coming. I have some business in Scandinavia. Can I stop by? So he did, and we had a great day. And
are you there every day? I mean, is there someone always there? So I'm taking a trip to Copenhagen because I feel like going to Copenhagen. And can I just knock on your door and be like, hey, can I see a rocket?
More or less, we would like a little, just an email and a heads up. But yeah, even though we are an all-volunteer organization, they are pretty much people in the workshop every day. Usually the activity starts after normal work hours, maybe 4 o'clock or something. Then people start to come in, and then there's activity all through the night, every weekend, all through the weekend. But actually more and more also during the normal daytime, the people are just popping in and working on different areas of the project.
Do you have any fun working stories from just hanging out with these people and building this stuff?
One of the things that I love most about this project is that everyone does it because they really, really want it. They love it so much, and also because they're pushing themselves.
Learn something new, try something you haven't done before.
Precisely, and you actually get to be with 50 other guys that in their specific area is way better than you.
So they can help you. So if you're not very good at welding, but you've got an expert welder there, rather than having the expert welder do it, he'll teach you how to do it.
Precisely, and that way we are all of us, we are pushing each other to be better, and that's fantastic.
So what's your area of interest? I mean, what's your expert area?
Well, expert would be a big word, I guess.
I don't like the word expert. What's your core competency?
I'm in electronics.
But you've done welding.
But I also weld. Yeah. Sure. I'm not an expert welder.
Neither am I.
No, far from it. But I do basic welding when we need something that doesn't need to be pretty. Then I can do it. And we do that. We all try to help out in all the different areas that we can. Just a few weeks ago, one of our lead programmers, Sten Andersen, he was helping our parachute guys, packing and packing the parachute and doing the parachute test. Because,
how are you gonna? Have you tested the parachute yet? How are you gonna? Yeah. That worked all right.
Yeah, the parachute works beautifully. We have had issues with the parachute coming out of rockets.
So as long as the parachute deploys, you're fine. It's the deploying part that it's going to be kind of important when a human's on board.
Yeah, precisely. the deploying part needs some work, but we're getting there. What we tested a few weeks ago was actually a reefing system. When we deploy the parachute, it needs to open just a little bit for a few seconds before we fully unfold the parachute. To not rip it apart because we're coming down at a huge speed. And we did some tests with that. There's a rule, I don't know if you know, but you can actually not test a parachute just by attaching some random cargo under it and dropping it.
I did not know that.
You cannot. You need to, at least in Denmark, you need to do a manned test of any parachute.
That makes no sense at all.
But anyhow, this is how
Wouldn't you want it to be the other way around? Would you want to test it with a non-living source?
I guess I would, but we have a very good working relationship with a local parachute club.
All right.
And they have parachute instructors that are more than happy to test our chutes. So what we do is we go down there. They go up in a little plane, and then he's called Ahmed, the guy who's testing our suits. And what he simply just puts it on, jumps from the plane, and then tests the parachute.
I hope he has a backup chute.
After a few minutes, so depending on the height, then he just releases our parachute, and then takes the final flight in his own parachute.
So you lose that parachute then?
No, but we have to drive far away. And last time I remember something about some crop and some fields somewhere that the guys had to find the parachute on a nearby field and recover it and take it back to the parachute club and then
angry farmers. Get off my property!
But that's how you do it. I mean, we have some contacts up in the Baltics where we probably can do some drop tests later on, because they have slightly different rules up there. Or we probably can use an old cargo plane to drop test a capsule, which we will have to do eventually.
as one does when they're building.
But again,
spaceships.
we need to test parachutes because we are also doing the parachutes ourselves.
So you're stitching them yourselves. Yeah. You're making them yourselves.
Yeah. We have 2 guys on our team who are experts in stitching parachutes. So
wow. So what other experts do you have? I mean, you got experts at stitching parachutes. I assume you have some expert welders.
We have welders. We have radio guys, electronics guys. We have aerodynamic experts. Sure. Basically everything. We have a doctor.
Oh, cool.
We basically have people from all the areas that we need to do this.
And you're all doing this in the garage. There's a picture we have of you guys hanging out.
Let's see that.
Like so there's a picture of you guys in a circle. There you go. Actually, that's the one. That's in a garage.
Yeah, this is a picture from we have our workshop is divided up into 2 areas, and this is our machinery workshop where we have all our mills and stuff. This is just a team briefing we had one day for a project, but this can actually give you an idea on how the workshop looks. It's not big. It's an old. We are working out of an old shipyard in Copenhagen. Where we rent a building, and that's you can see there. That's outside our workshop. Our flight director doing a briefing before the Heat 2X test.
And this shipyard's where you built your submarines.
Yeah.
Right. It's where you built and launch your launch platform from, like launch it out to sea.
Yeah.
It's also where you build your rocket. So it's kind of your home base of operations.
And it's also where we have our test stand.
Mm. There was a beautiful shot. I don't know who framed it, but tell them that I love this shot of your engine with like a windmill in the background. It was exactly how I picture you guys. It was like, yep, nope, that's Copenhagen. So yeah, and you test your stuff right there.
And that is the beautiful thing about where we are located, because we actually have this huge old shipyard that has been decommissioned for 30 years or something, and now it's kind of a community where we have artists and all different kind of startup companies and stuff renting spaces all around. But we have the dock area and the area where they used to drag out the sections of the ships from the big assembly halls. And during the winter time, especially, that is totally deserted, which means that we can have our test stand and we can do rocket tests out there, because that's just a huge abandoned area.
So does testing in the winter better or worse for you? Because it's going to get cold in Copenhagen.
Yeah, it is. It is actually a little bit better than testing in the summer, because the humidity is very low. So and that obviously is an advantage when working with the liquid oxygen, because we don't get as much water freezing on all the pipes. But apart from that, I mean, I would prefer 20 Celsius. And a light work suit. When you're testing and working during the winter, you have to have thermo clothes and gloves and whatever. But that's just how it is. I mean, when you're working and having fun, it's not that bad.
Do you have any timelines? Are you like, okay, we really want to get this done in the next year? Or is it more of a, we're just going in having fun, and when it gets done, it gets done?
I think we would like ourselves mostly just to have fun, but we also need to have some deadlines to put some pressure on ourselves. So the plans right now are that we will launch the first prototype of the Spiker rocket in 16, the summer of 2016. In the next couple of months, we will have some test firings of our new small-scale prototype engine, and hopefully sometime next summer, we will have the first test firings of the big 100 kilonewton engine that we will use for the Spiker rocket.
The great thing about you guys is I know you're going to stream it live if you can.
Oh yeah.
You love to show all of it, the entire creation. Actually, you were talking about you're going to do something more with cameras inside, aren't you? Like so you can watch.
Yeah, we have talked about that at least. We have talked about.
I'm committing it to you now, just so you know. Now you're committing to it on national television.
We have talked about doing some live shows from the workshop, but otherwise, our workshop, as I said before, is always open. We have had people from all over the world asking us for drawings and stuff, and we will share what we can. Sometimes we don't have actual plans because some things are devised as we are building them, but we will share whatever we can. But our doors are always open. People are welcome to stop by and see what we're doing, and we will of course live stream everything. Every single test we do, we will put that online, and we will show pictures. And if things fail,
when they should. Yeah. This is the time. This is the thing that everyone seems to forget, is that you are still development. This is the time when you should fail. You should take the knob and turn it to 12 and see if you can break it. You should. There are times when you purposely want to break things. I mean, not always, but this is when things should fail.
We have planned about 15 tests of the small scale engine, and we expect it to fail at least half the time.
That seems fair.
And we will show that, and we will live stream everything, and we
will be glorious.
Take pictures of the autopsy of the engine afterwards, and we will tell everyone what went wrong, because that's also some of the fun of it. It's not just fun to see 100% successful launch. It is also fun to see the failures, but most of all, it's fun to know what actually went wrong, because it doesn't matter if you fail as long as you learn from it.
Absolutely. Absolutely. If you fail and learn nothing, then that truly is a failure. If you have a rapid, unscheduled disassembly of a part and you learn a lot from it, then I wouldn't really classify that as a failure. It's a learning experience, right? You lost your engine, but you learned a great deal from it. So that's not a failure at all. All right. Once again, where can people go to contribute and help Copenhagen Suborbitals if they think that what you're doing is interesting and awesome? Which, by the way, it is interesting and awesome.
They can just go to our website, copsub.com, and by the way, on that website, we have all our videos, all our images, everything, stories. You can read everything about us. But then click on the little support tab out on the right side of the screen, fill out the form, and voila, then you are a Copenhagen Suborbitals supporter. And we really much appreciate it.
And, before we go, I think here's one other image that we didn't get to. This is your ship.
Oh yeah, the Vostok. We have a tendency of naming our vessels from things that were first in spaceflight, and the Sputnik and the Vostok were two first from the.
And you use this to go out to your platform.
Yeah,
right? The humans are on this. The humans aren't on the platform.
If we can just stick to this image a little bit, I can tell you about it. This is actually a beautiful ship. We are very proud of her. She is an old German rescue vessel that we bought a couple of years ago, very cheap, from some Norwegians, by the way, which has nothing to do with the story, I guess. But we did. She is a 100% aluminum and has a 900 horsepower, 12-cylinder diesel engine. So that ship is a beast.
I bet.
And it is fantastic, but it has, and you cannot see it on the picture, but one of the reasons we bought it is it actually has a cradle on the back of the ship, where you can lower the rear end of the ship. You can lower it down, and then it has a triangular cradle that is perfect for pulling up a capsule at sea. That was it used to be intended for a small rescue boat that they could deploy out at sea, but now we have converted it into a rescue vessel for spaceflight. And this is also our command ship. It is filled with electronics. We usually make fun of our radio guys and saying he's trying to make it look like a sailing hedgehog because there's antennas everywhere and it's packed with electronics. But we have all our mission control equipment is on that ship.
So I know I'm supposed to be going to break, but forget that. You had actually mentioned earlier before the interview that a lot of the money doesn't necessarily go into the rocket; it actually goes into the support infrastructure, and this seems like one of those support infrastructure.
Yeah, and that is actually one of the surprising areas, I guess, of all this. That we have a budget of around $20,000 a month.
Mm-hmm. That's not bad. I mean, that's not a lot, but that's not bad.
That's what we're working for. We of course we could use some more. I mean, building rockets is like burning dollar bills in your backyard.
You've heard the joke, how do you become a billionaire in rocket science? I'm sorry, how do you become... I screwed up the joke. I screwed up the joke. How do you become a millionaire in rocket? You start a billionaire. That's how you become.
Yeah, precisely. But oh, now I lost it. What were we talking about? We were talking about...
how you...
and the support infrastructure, sorry. The rockets themselves are not that expensive because it is mainly... The cost is mainly remember we have no paid labor at all.
It's all volunteers.
It's all materials, and I think the latest one, the 2X, was about 250,000 Danish kroners, which is I cannot really convert that into dollars in my head right now. You can do that if you have a calculator.
Someone on the internet can figure that out.
That is about but the infrastructure around all this. I mean, maintaining ships, building launch platforms. Building our test stands, keeping the workshop running, all that actually takes up quite some money.
Yeah, I can imagine. I mean, even the cranes.
Every time we have to do something, we need to rent a crane.
I bet I can only imagine that you guys are you look at the cost analysis of, does it cost us more to rent this or just build one ourselves?
Precisely, and that's why we sometimes just say, well, it may take a little bit longer, but let's just build it, because we have some small scale cranes actually that we build ourselves, and that being said, we also have very good neighbors at our facility. We have some television studios. Is one of our next door neighbors.
Oh, maybe I should move over the I could get. We're in our apartment. I could go for a television studio space.
You could broadcast from the submarine, I guess.
Oh, that would be cool. I want to go broadcast from the moon though. So once you get someone into low Earth orbit, you need to figure out how to get me to the moon so I can broadcast from there.
Yeah.
Ideally, not this. I don't want to travel this way the whole time though. Like 3 days like this, I think my arm would cramp.
We need to.
If I can just maybe like this.
If you can wait a few years, maybe we can talk about that.
Oh yeah, absolutely. I'm cool with that. All right, we're going to go into a break, and we're going to talk about comments from our last week's show, but you're around for a bit, so you're going to come back after dark. We're going to talk about more just fun stories from Copenhagen.
Sure.
Hey, thank you so much for coming on the show. This has been a lot of fun.
It was a pleasure.
For those of you who are Patreon Plus subscribers, After Dark will be made available immediately to you after this episode is complete. Otherwise, for the rest of you, it'll be available in 4 weeks. Stay with us. We'll be right back.
1, 0. Liftoff.
The fleet of space shuttles were doing amazing things in space.
We've got all your space geekery right here.
And welcome back to Tomorrow. Now, before we get started with comments from our last week's show, I'd like to give a huge shout out to all the Patreon subscribers. These are the people who've contributed at least $1 to this specific episode. You can find more information on this over at patreon.com/TMRO. Again, crowdfunded show, even $1 per episode. That's less than a cup of coffee. Starbucks coffee, at least. Less than a cup of Starbucks coffee can help us stay on the air and do really cool interviews like with Copenhagen. And hopefully, I would love to actually head over to Copenhagen and do a show from there. Wouldn't that be awesome?
Yeah.
That would be really freaking sweet.
Duh.
So, all right, let's go ahead and get started with some comments from our last show. This first one, Dutta, are you commenting again?
Always.
Should we have Dutta read it?
Sure.
Ready? All right, go. Ready,
Dutta
says...
The European IXV looks like a penguin. It's a space penguin.
Oh, Dutta. It does actually. With those little paddle things, it does in fact look like a space penguin.
Yeah.
That's what it looks like.
That's legit.
Why we let him in the chat room, I don't know.
I don't know either. I don't know. Oh, well.
All right. From Patreon, Brendan.
Brendan Caulfield says, I love what Paul and Matt are doing with Chasing Atlantis. So much heart and sincere awe poured out of them in the interview that I simply cannot wait to see the film. I'm off to their YouTube channel momentarily.
Oh, you're going to leave off the Carrie Ann? Your interview was impeccable.
It seems weird to like say something about
yourself.
myself.
All right. Well, I thought it was her first interview, and so I thought she did a fantastic job. A first solo interview, at least. I thought she did a fantastic job.
Yeah.
And I agree. I thought she did a really great job, and I love Chasing Atlantis and what they're doing. It's exciting to see other people get excited about space like that.
Yeah.
And I'm going to use the word excited again because I can't think of another one. To see that final documentary when it's all said and done.
Yeah, no, that should be a lot of fun.
Next up on Reddit.
From Colossal Thrust says, I've often wondered why Carrie Ann didn't do interviews. This needs
Me
to happen
too.
more.
Yeah.
Everyone knows why I don't do interviews. Anyway, as logical as it is to have the more technically knowledge Ben do interviews with the individuals doing the more technical stuff, this episode in particular demonstrates that not everything about Space Geeks is technical.
That's true.
Carrie Ann is lively and shows sincere interest in the guests and responses. This is not to discredit Ben in any way, but a woman's touch. Just saying.
No, absolutely, you're right. And actually, I think that hits the nail on the head.
Awkward for me reading that. So
I know.
sorry.
I enjoy making this as awkward as I can for you. I'm enjoying this moment.
Ridiculously awesome. Thanks.
No, I actually agree. You know, not everything needs to be technical when we're talking about space. Sometimes it can be just about the more, I don't want to say ethereal stuff, but the less technical stuff. It doesn't have to all be numbers and bending metal. It is just cool sometimes.
The human touch.
The human touch, exactly, Dada. Thank you.
Well, you're not an android.
Well, not yet.
All right.
Not yet. I am working on that.
All right,
I'm working
all
on
right.
that.
So,
from
thank you.
From YouTube.
FPV Review says, since this show is about tomorrow, could you actually just review comments from the next episode, please?
I like that one.
I'd love to, but they come in bits and pieces, and it's really hard to decipher.
Actually, most of the comments I have to ignore. So the first thing I'm doing from the comments that are yet to be released are the person who writes first. I'm deleting that because I always go back and delete those.
Right.
Right. And then I'm laughing at the people that are fighting over technical information where they're both right and they're both wrong.
Right.
So I'm laughing at those comments. And then FP Reviews says, I should have actually written this up. FP Review will say on our next episode how amazing I am at what I do and how FP Reviews wishes they could be more like me. So there you go.
Don't we all?
That's hey, dude, it's a future comment. I can't help it. It's science. What do you want? What do you want?
Wow.
Also from YouTube.
Halvarekna says, perhaps I'm not a hardcore space geek, at least not in the right way. Perhaps that's why I didn't find this week's interview very interesting. I'm interested in space, not so much the space geek community celebrating itself as a subculture.
Yeah, I can see that's actually fair.
Totally fair.
Yeah, we're not, we generally don't try to do the inside, forgive the phrase, we try not to circle jerk too much inside of the space community, right?
Right.
But when you've got a passionate group like Chasing Atlantis doing something like that, yeah, we're going to give them some airtime because what they're doing is important and it's really cool to what's going on out there and they can offer insight that otherwise maybe you wouldn't be able to see. And that's kind of what we do. We're not just here to give you news in stark, like, this is what's happening, we're not going to break news. We're here to get you excited about space. And sometimes that means bringing on people that are doing other stories about space. Sometimes that means bringing on Copenhagen Suborbitals, and sometimes that means bringing on Elon Musk. Whatever it takes to get you excited and passionate about putting humans in space. That's what we want to do. For me, I will tell my personal story. If you go back even 2 years, I basically said makerspace wasn't a thing.
Yep.
On the air, on this show, I'm like, no, they will never amount to anything. They can't do anything other than these little CubeSats, which are pretty much useless. Yay, they're fun for fun little parties, and you'll get a little bit excited, but then it poops out. The fun, real stuff is human spaceflight. And then comes along Copenhagen Suborbital and turns me on my head, right? And I completely 180 my opinion. They are absolutely changing everything I ever thought about space and makerspace, and what is capable, what someone can do if they just say, look, we're not trying to build the best of something. We just want to do this.
Right.
And
see, sometimes he does eat his words.
No, of course. Look, when the data changes, I'm allowed to change my opinion.
I
yeah, absolutely.
I think a lot of people though view you as being very soapbox oriented, and this is the way it is, and this is the way it's always going to be, and so this is a beautiful example of that you are perfectly willing to accept that you were wrong,
sure,
and admit it on air.
Well, of course, I was.
Well, right.
I was. But back to the comment of, I don't understand why we would celebrate space's inner workings. And it goes down to the idea that, even with the, I didn't think that Makerspace could do this, celebrating all of these different types of space communities is a good thing. And if it gets you excited, awesome. If you didn't find that particular episode exciting, that's okay. This is episode 32 of this year alone. So hopefully a previous episode or a future episode you will find exciting. We will always try to find something engaging for you. So there you go. So that was a little soapboxy. I'm sorry. I probably went way off the. And I think Halvor. I think comments are valid, right? The show's not going to be great for everyone. So I'm not ripping into Halvor. I think that was a very valid comment.
Absolutely.
But yeah, I figured it was worth pointing that out. And finally on YouTube,
Clint Young says.
Clint Young. That's a name.
That's his name.
That's a name.
Says, great show, but y'all need LED lights.
Yeah, well, we're not at that $1,000 Patreon mark yet. Which, by the way, we did just crest the $700 mark. Per episode. Nice. Yeah, so we're $300 away from our next Patreon goal. I'm sure you guys are sick of us talking about Patreon, but too bad I'm going to anyhow. Well, it helps. It's what lets us do cool things.
I know.
So the next up is the swag store, because we have a really cool logo that is going to appear on the screen in a moment. There we go. We have a really cool logo that I helped make, and I want to put it on mugs. I want to put it on. We've got really cool pins. We want to put it on pens. We want to put it on things that you can then go out there and wear. And we don't have to charge you an arm and a leg, but we want them to be halfway decent quality products. Not that horrible little like cafe press stuff, like real good things. And there's an out-of-pocket expenditure for that. So at the $1,000 level, we open our swag store. Then a little bit after that, these lights are going away. And in fact, we are going to throw some LED lights in this bad boy all up on, because, man, it gets hot in here.
It's really hot.
If you watch, here's a little hint. If you watch at the beginning of the show, and then you just fast forward to the end of the show, you can actually see the change in temperature in our face, because it does raise a good 10 degrees in this room just by turning these lights on and the air conditioning off. So, yeah, but for me right now, it's more important to have that swag store than it is to be comfortable while sitting on the set. All right, that's our show for this week. After Dark is up next. I'd like to thank everyone so much for joining us. We'll see you next week, but remember, after next week's show, Daylight Saving Time kicks in. November 2nd, Sunday, November 2nd, Daylight Saving Time. This show is always 2100 Coordinated Universal Time. Always, always, always. If you honor Daylight Saving Time, then 2 weeks from now, the time of this show will be changing for you, and it will be 1 hour earlier than it is now. If you do not honor Daylight Saving Time, then this show time will not be changing for you. Once again, the show's time is 2100 UTC. For more information, you can hit up worldtimeclock.com or check out our live stream page, and we'll count down to the next event. Thanks so much for watching. See you next week.